Hi everyone, a good morning to all of you. Now today we are going to study about the question number 45 related to electromagnetic waves. So the very first thing here what we have to understand is what is electromagnetic wave. See here, electromagnetic wave is nothing but one transverse wave, and it is a non-mechanical wave, means which does not require medium. Of course, it can travel through medium also, and associated with oscillating electric field and magnetic field such that direction of propagation, comma, E bar and B bar, all the three perpendicular to each other. Such kind of wave we call it as like three should be perpendicular to each other. So direction of propagation, electric field and magnetic field. Always all the three must be like perpendicular to each other like along x, y, z. So such kind of wave which is always associated with oscillating electric and magnetic field, we call it as electromagnetic wave. And the next thing is there are different type of electromagnetic waves, and in vacuum the speed of electromagnetic wave is 3 into 10 power 8 meter per second, and in any medium the speed is also given by under root mu naught epsilon naught, where mu naught is permeability of free space, epsilon naught is permittivity of free space. And in any medium it will become C by mu or C by n. Better to write C by n, where n is refractive index. That means in a medium the speed will become 1 by under root mu epsilon, where mu and epsilon are permeability and permittivity of that particular medium, and that we can write it as mu naught mu r, epsilon r, then nothing but 1 by under root mu naught epsilon naught, 1 by root of mu r epsilon r, nothing but C by under root mu r epsilon r. So the refractive index is under root mu r epsilon r, relative permeability and relative permittivity. So this is the equation of speed of an electromagnetic wave. And the next thing what we have to understand here is what is the equation of an EM wave. Now let us consider an electromagnetic wave traveling along x-axis. Let us consider any one direction like x-axis. Then electric field will be oscillating along y-axis and magnetic field will be oscillating along z-axis. So E equal to E naught into sine omega t minus kx. Similarly, B equal to B naught sine omega t minus kx. So omega t minus kx means the wave is traveling along x-axis. Ey means it is along y-axis. Bz means it is along z-axis, such that all the three always perpendicular to each other. And from the equation, the speed of the electromagnetic wave is omega by k. That is nothing but F into lambda. So this is what the equation of an electromagnetic wave. Now, the next thing is, what is the intensity of electromagnetic wave? See, average energy density, average energy density of electromagnetic wave is given by half epsilon naught E naught square or half B naught square by mu naught, where E naught equal to CB naught. So the relation between amplitude of electric field and magnetic field. Now, similarly, the intensity of an electromagnetic wave. So intensity nothing but power per unit area. That intensity is given by half epsilon naught E naught square into C or half B naught square by mu naught into C. This is the intensity of an electromagnetic wave. So based on which they can ask questions. And sometimes they'll also ask about the Poynting vector, that is S bar equal to 1 by mu naught E bar cross B bar. So just try to remember. So the energy crossing S bar represents that the direction of propagation along which the energy carries. So the direction of propagation always perpendicular to E bar and B bar. That is nothing but E bar cross B bar. So remember all these formulas based on which they can ask questions. Also, sometimes they can ask the different wavelength range of or different frequency range of different electromagnetic waves, whatever 7 different type of electromagnetic waves are there. That is based on electromagnetic spectrum like microwaves, radio waves, X-rays, gamma rays, all those things, visible rays, UV rays, all those things. So you please try to remember the range of wavelength range or frequency range, or better to remember the wavelength range so that you can calculate the frequency range of all those electromagnetic waves. So gamma rays, X-rays, UV rays, visible rays, and microwaves and radio waves, like that, all the things, please try to remember it. Now, here is the first question. Electromagnetic waves travel in a medium with a speed. So the speed is given by, in a medium, 2 into 10 power 8 meter per second. The relative magnetic permeability of the medium is 1. So mu r is 1. Find the relative electrical permittivity, that is epsilon r is how much? Now V equal to C by under root mu r epsilon r implies V square equal to C square by mu r epsilon r. Then epsilon r equation will become C square by V square into mu r. C square means 3 into 10 power 8 whole square by V square means, so 2 into 10 power 8. So 2 into 10 power 8 and mu r is 1. Cancel, cancel, cancel. So 9 by 4 or 1.5, 1.5, 2.25 will come. So this way you can solve the questions based on the formulas whatever we have seen. Now here one more question, an electromagnetic wave of frequency. They have given the frequency that is 40 mega. Mega means 10 power 6. Travels in free space in the x direction. Determine the wavelength. See C equal to F lambda. So lambda equal to C by F. So C value you know, F value they have given. And at some point and at some instant, the electric field has its maximum value. That means E naught value, the amplitude of electric field is Newton per Coulomb and is along y-axis. Calculate the magnitude and direction of magnetic field at this position. Now B naught equal to E naught by C. Then you will get the magnitude of magnetic field amplitude. and this must be, as wave is along x direction and electric field is along y axis, this must be along z axis, because all the three must be perpendicular to each other. Now find the amplitude of electric and magnetic field in a parallel beam of light of intensity. So intensity formula is what I have given, half epsilon naught E naught square. So that E naught square equal to 2I by epsilon naught. So that E naught equal to under root 2I by epsilon naught. One formula. And another one is intensity also equal to half B naught square by mu naught. So that B naught square equal to 2 mu naught I. Then B naught equal to under root 2 mu naught I. Now here epsilon naught I, and like just I been showing you, under root 2 into intensity is 4. Epsilon naught is 8.8 into 10 power minus 12. Now here under root 2 into mu naught is 4 pi into 10 power minus 7 times I is 4. So if you solve it, then you will get the answer E naught and B naught value. Now one more example, it is based on the equation. The magnetic field in a plane electromagnetic wave is given by, they have given the value, and if you can compare B naught into sine kx plus omega t or omega t plus kx. So in the place of B naught, they have given as 2 into 10 power minus 7 Tesla. And the x coefficient is k, wave number 2 pi by lambda, that is 0.5 into 10 power 3. And t coefficient is omega, that is 1.5 into 10 power 11 radian per second. Now, what is the wavelength and frequency of the wave? Wavelength you can calculate from here, and omega equal to 2 pi by t, nothing but 2 pi f, you can calculate frequency. Now write an expression for the electric field means Ex equal to E naught into sine omega t plus kx. Sorry, not Ex, it is moving along x-axis. Magnetic field is along y-axis. So then you have to take it along z-axis, where omega and k remain same. Only E naught changes, where E naught value will become what? C B naught. So you have B naught value, you know how to find C value. So that way you can find the value. Now, one last and final question. In a region of free space, the electric field at some instant of time is E equal to. So they have given electric field something 8 I cap plus 32 J cap minus 64 K cap. And the magnetic field also they have given, that is 0.2 I cap plus 0.08 J cap plus 0.29 K cap. And the magnetic field it is in micro Tesla, this is in volt per meter. So unit is also important. So this is micro Tesla. So micro means 10 power minus 6. Show that these two fields are perpendicular to each other. Now these two are perpendicular means you have to find dot product. Then 80 into 0.2 plus 32 into 0.08 minus 64 into 0.29. If it is 0, then you can conclude that the both are perpendicular. If it is not 0, then you can conclude that they are not perpendicular to each other. Now determine the Poynting vector for these fields. So Poynting vector means what I said, 1 by mu naught into E bar cross B bar. Then you have to find the determinant using I cap minus J cap K cap, like how we find for the what we call it as cross product, we have to find in the similar manner. Like in the first row, we have to take the coefficients of E bar like 80, 32, minus 64. Then in second row, we will take coefficient of B bar 0.2, 0.08, 0.29. So if you look at this question, the calculation is little bit difficult, I mean lengthy. But in the examination, they'll not ask 2-3 questions in one question. Any one question they'll ask. So as it is for practice, you just try to understand and try to solve it. So this is how the simple questions they'll ask based on the electromagnetic wave equation, speed of electromagnetic wave and intensity of electromagnetic wave or energy density of electromagnetic wave. So similar kind of questions I have given as an assignment. So please try to solve them. And also, if you look at the NCERT questions based on the same topic, so there are a lot of questions they have given. So please try to solve all the questions. So thank you all. We'll continue in the coming class with the next question.